Hello everyone. So in this video, I'll be discussing three past year questions. No, these are not the past years. Three back exercises questions of chapter 12 itself. So the fourth and fifth one are a bit easy. So we'll start with the fourth one. For what values of x is the scalar product equal to 0? So we have x minus 1, 3 dot product x 3x, so this should be 0. we this gives us x square plus x minus 1 into x plus 3 into 3x equals to 0. So we have x square plus x square minus x plus 9x equals to 0. This gives us 2x square plus 8x equals to 0. Taking 2x common, we are left with x plus 4 equals to 0. So when this is 0, when either 2x is 0, we have x equals to 0, and the other is x plus 4 equals to 0. So x plus 4 equals to 0 implies x equals to minus 4. So these are the basic question only. Now I would suggest you solving the fifth question by your own. For what values of x are these two vectors orthogonal? So two vectors are orthogonal if their dot product is 0. So we have x minus 8, x comma x dot product. So if they are orthogonal, you need to mention that a dot b equals to 0. So if a is this, b is this, dot product with x 1 minus 2 and 1. So the dot product would give us x into x square plus 1 into minus x minus 8 plus x into minus 2 plus x into 1. So we are left with x square minus x minus 8 minus 2x plus x. This cancels out. X square minus 2x minus 8. So you can solve this. This is 0. So x would be minus b plus minus under root b square minus 4ac upon 2a. Then accordingly you can find the value of x. Now moving to the next question. Okay, so these types of questions you can expect coming in the exam. A firm has two plants that produce outputs of three goods. So how you are supposed to start the answer? You need to mention given two plants. You need to mention these things as well which are given in the question. And the firm produces three goods. You need to mention all of them. Its total labor force is fixed. When a fraction lambda of the labor force is allocated to its first plant and a fraction 1 minus lambda to its second. So basically total labor force is L, where lambda is being given to the first plant. Lambda times L labor is being given to the first plant, where lambda would lie between 0 and 1. And 1 minus lambda times L is given to the second plant. The total outputs of the three goods are given by the vector lambda times. So this would correspond, this coefficient 8 corresponds to the output produced in the first plant. Output of the first good produced in the first plant. This for the second good, and the last one for the third good. Okay, now with the help of this, what we have is, if lambda is being devoted to plant 1, then the production of good 1, suppose good 1 we denote by x1, this is given by 8 into lambda plus 2 into 1 minus lambda. So this becomes 8 lambda plus 2 minus 2 lambda. So this is 6 lambda plus 2. So x1 we have 6 lambda plus 2. Similarly, we can find for x2. x2 would be 4 times lambda plus 6 times 1 minus lambda. This becomes 4 lambda plus 6 minus 6 lambda, which is 6 minus 2 lambda. So we have x2 equals to 6 minus 2 lambda. Similarly, we can find for x3. Okay, similarly, x3 would be 4 lambda plus 1 minus lambda times 10. So this becomes 4 lambda plus 10 minus 10 lambda. X3 is, so this becomes 10 minus 6 lambda. So we have x3 equals to 10 minus 6 lambda. Now the first question is it possible for the firm to produce either of the two output vectors? In this case, this is x1, this is x2, this is x3. So we need to check whether the firm can produce this or not. So substituting x1 equals to 5, we have 5 equals to 6 lambda plus 2, 3 equals to 6 lambda. This gives us lambda equals to half. Now what does lambda equals to half means? That half of the labor force is being devoted to production in the first plant, and similarly the other half is being devoted to the production in the second plant. Now substituting for x2, x2 was 5, so 5 equals to 6 minus 2 lambda, then 2 lambda is coming out to be 1, lambda is coming out to be half. Okay, same thing. So it should be same throughout. And x3 was 7, so 7 equals to 10 minus 6 lambda. Okay, so 7 equals to, x3 was 7, 4 lambda plus 10 minus 10 lambda, 10 minus 6 lambda. Okay, so 10 minus 6 lambda. So we have 6 lambda equals to 3 and lambda is coming out to be half again. So if we devote half of the labor force in the production for the first plant, then this output level can be produced. Okay, so we have got this. Now looking for the second output. Okay, here x1 is 7. So ideally we should have 7. I'll use the blue one only. So we should have 7 equals to 6 lambda plus 2. So we have 6 lambda equals to 5. So lambda is 5 by 6. Now looking for x2. x2 is 5. So 5 should be 6 minus 2 lambda. So 2 lambda is 1. Lambda is coming out to be half. So what we can see is there is, to produce x1 and x2, the value of lambda is coming out to be different. So which is not possible, because you are supposed to allocate the labor in the one go itself. So we cannot produce this output level. Similarly, we can check for the third one as well. So 5 equals to 10 minus 6 lambda. So 6 lambda equals to 5, lambda equals to 5 by 6. Okay. So when lambda equals to 5 by 6, that is, we are devoting 5 by 6 of the labor force for the first plant. x1 can be produced, x3 can be produced, but x2 we cannot produce this. So this output vector cannot be produced. Okay. So it was mentioned that if outputs cannot be thrown away. Now the second part of the question asks us, okay, I erased all. How do your answers to part A change if outputs can be thrown away? So in this case, even without throwing the outputs, we were able to produce this. So we will be able to produce this now as well. Now, if outputs can be thrown away, so we know x1 with the help of this was 8 lambda plus 2 times 1 minus lambda. So this was 6 lambda plus 2. So this x1 should be greater than 7. So this is the condition. It should be greater than 7 if outputs can be thrown away. So you are devoting labor in such a manner that the output produced would still make it more than 7. Similarly, for x2, we have x2 was 4 lambda plus 6 times 1 minus lambda. So this is 4 lambda plus 6 minus 6 lambda, which is 6 minus 2 lambda. So 6 minus 2 lambda should be greater than equal to 5 if outputs can be thrown away. And then x3 was 4 lambda plus 10 minus 10 lambda, which is 10 minus 6 lambda should be greater than equal to 5. Now, with the help of these three equations, if we are able to find a lambda, then this can be produced, this output can be produced if the outputs, some of the outputs can be thrown away. Now, x1 gives us 6 lambda plus 2 should be greater than equal to 7, which means 6 lambda should be greater than equal to 5. Lambda should be greater than equal to 5 by 6. So what we have is that lambda should be greater than 5 by 6. So on a number line, lambda can take value between 0 and 1. So we are having that lambda should be greater than equal to, so 5 by 6. So this area, including 5 by 6. Now for x2, to have x2, we need 6 minus 2 lambda should be greater than equal to 5, which gives us 1 should be greater than equal to 2 lambda, which means lambda should be less than equal to half. So to produce x2, we are having the scenario, this one. Since there is no overlapping, what we have is, it is not possible to produce this lambda. So it is not possible to produce this output level, even if the output can be thrown away. So you need to take into consideration this, I'm marking in red, these sign if outputs can be thrown away. Okay, now moving forward to the last part of the question. So you can expect these types of question coming from this, and this is very logical. Now look at the last part. How will the revenue maximizing choice of the fraction lambda depend upon the selling price P1, P2, P3 of the three goods? So what we have is, selling price is given to us, the vector P1, P2, P3. Now they are asking of the three goods, and x1 was 8 lambda, I'll 2 1 minus lambda, I'll 6 lambda plus 2. x2 was 4 lambda plus 6 into 1 minus lambda, 4 lambda plus 6 minus 6 lambda, which is 6 minus 2 lambda, and x3 was 4 lambda plus 10 minus 10 lambda, which is 10 minus 6 lambda. So now the total revenue would be price into quantity, so which is P1, P2, P3 dot product x1, x2, x3. So now x1 is 6 lambda plus 2, x2 is minus 2 lambda plus 6, and x3 is minus 6 lambda plus 10. The dot product would give us P1 6 P1 lambda plus 2 P1 minus 2 P2 lambda plus 6 P2 minus 6 P3 lambda plus 10 P3. So this is the total revenue, which is expressed in the form of prices and the lambda. Now the total revenue, this can be further simplified as 2 P1 plus 6 P2 plus 10 P3. So we have marked this, this and this, plus lambda times 6 P1 minus 2 P2 minus 6 P3. So this is the total revenue of the firm. Now, what condition must be satisfied by the prices if both plants are to remain in use? Firstly, this is the total revenue. Now look at it very carefully. Prices are always positive, positive, positive. So whole this term is positive. Now, if the price relation is such that this term is coming out to be less than 0. If this term is coming out to be less than 0, then if you give any positive value to lambda, your total revenue would fall, because if lambda is positive and this term is negative, this whole term would be negative, and this would lead to reduction in total revenue. So if this term is okay, so if this is coming out to be less than 0, then we should have lambda equals to 0. That would help us in maximizing the profit. So if lambda is 0, what does that mean? So if we have 6p1 minus 2p2 minus 6p3 is less than 0, we should have lambda equals to 0, which means 0 labor should be allocated to the first plant and all of the labor should be allocated to second plant. This is the economic interpretation for this. And if this term is greater than 0, if 6p1 minus 2p2 minus 6p3 is greater than 0, then this is already positive, and if this is positive, we would prefer to have lambda to be the maximum possible value, which is 1, because in that case the revenue would be maximum. So in that case lambda should be equals to 1, which means all the labor is being devoted in the production in the in the first industry, in the first plant only when lambda is 1, and in the second plant it should be 0. Now what condition must be satisfied by these prices if both plants are to remain in use? So we have taken two cases. Case 1, when this equation was less than 0, then we will have case 2 as well. Case 2, when this is greater than 0, and lastly case 3, where 6p1 minus 2p2 minus 6p3 is exactly equal to 0. So in this case, if this term is marking in green, if this term is coming out to be 0, then irrespective of what the value of lambda is, so if in this case if lambda can stay between 0 and 1, because it really doesn't matter what value does lambda take, the total revenue would be this particular thing. Okay, so both plants will be in use when lambda is strictly between 0 and 1. So in this case both would be used, and the condition is this. Okay, I hope this you could get to know about how to approach this question, and you can expect some of the questions coming of this type. Okay, all the best, and from the next class I'll be starting with chapter 13.